All right. Hello, Physics 30. Today I'm going to start teaching you about vector addition mathematically, calculating the vectors instead of doing it graphically. Now, the advantage of graphic vector addition is that you can add a whole lot of them together rather fast. So if you have, say, 5 vectors, which you don't necessarily usually have, but say you had 5 vectors, you can find the resultant vector fairly fast using the graphical method. It's not super, let's say, precise because you're using measuring tools and you're a human, but it's quite good for that. Now, it's also really good for, the graphic method is really good for things that are not at 90-degree angles from each other. Okay. Now, what's the calculated version good for then? It's really good if you want more precise values, and you take the human error out of it. And so it's quite nice. But the trick is that you have to calculate, you have to manipulate equations, and you can notice up here that actually there are a lot of equations up here. And something you're looking at and you're like, please no. Usually in class time, I take the time to go through each one, and you'll remember that some of these look quite familiar, or they should anyway. Top ones should, and then these ones here are just modifications of, well, these two are modifications of this, and this is just a modification of that one, and this one's also like that. So anyway, so I'll go through, I think in this video I'll have time to go through 2 vectors at a right angle of each other, and then I'll go through one that's not at right angle, and then I'll make another video to show you kind of like a deluxe version of how to go through this, and this is, or how to get the x and y components. Now I'm using f of x and f of y. That's just force. It could be distance, it could be, or displacement, I should say, or it could be velocity, or it could be acceleration too. It can be any vector, but I just use f because that's the one that we typically talk about in physics. We usually talk about how force vectors are added together and stuff like that. So let's start here. And you'll notice that these numbers, at least hopefully, I created the same numbers as the one that we did graphically. That was intentional so that you could double check. I will also post all the answers here, but that way you can double check from the ones that you did graphically and see if you're way out to lunch or not. Okay, so let's go down here. This is d1 plus d2. So these are 2 displacement vectors. Not distance because they have a direction. First thing you want to do is put in your reference. Oh, let's just see here. There we go. Wow, that is not straight at all, but just pretend that it is. All right, so here we're putting our coordinate system. This is north, south, west, east, and again, this here, west to east, spells we, so I know I've got it right. I used to always flip them around when I was a kid. All right. Distance 1 is 35 kilometers at 25 degrees north of east. So we have a sense of what that would be. This would be something like this. That's maybe a little high, and then the D2, this would be east of north, so this one's more vertical, but it's a lot shorter, so it's a shorter one, kind of like that. This one here would be 20 kilometers, 43 degrees south of east, so that one's actually the 45-degree angle, and this one is south of west. Wow, sorry, that's a huge mistake. South of east would be this direction. Sorry about that. This is south of west, so this one is more like that kind of arrow. Anyway, so these are the vectors. Visually, that's what they kind of look like. And I'm going to change my pen so that we have blue ink. And we're going to add these 2 together. So to do this mathematically, first I'm going to show you, I'll draw you a diagram just so that we get the math right. You might be able to visualize it, but it's nicer to get the math right. Now, sorry, I was gonna say that we're gonna do one with a right angle and then ones without right angles, and actually the right angle question is coming up later. So anyway, I should start with that though. So maybe let's let's modify this a little bit. I'm just going to say this is going east and the other one's going north. So let me modify the question a bit. So this is more of just a tutorial for now, and then we'll get back to that. So we're going to just say that it's just going east, and then this one's just going north, just so I can show you. And then maybe I'll switch it to the real one, and I'll answer A. So this is the special A here, special right angle version. Okay, and so one's going east, so one's going straight east like that, and the other one's going north, straight north like that. Okay, so let's add those two together. So we would have 30. Wow, should I bring the ruler out, or should I just be more careful? Let me try to be more careful first before I bring the ruler out. All right, so it's something like that, 35 and then 15. And I tried to draw it kind of to scale just so that you can see what it will end up being. Now the resultant vector will, and I'll draw that in green, the resultant vector will be starting from here. And again, I'm drawing it with dotted line. The reason I usually do dotted line is just so you can tell the difference, but it's also green, so that helps. And I don't know what this is, but this is what we're trying to find out. So then the question is, how do we find that out? Well, the beauty of this is these things are at a right angle, and so this is a right angle triangle, and so you should recognize up here that this one here can be used with a right angle triangle, and so can this. And to be sure, this can and this can as well, but these are actually more powerful than these two. These are like the special, more specialized version or specific version, but these are more general. So we're going to use these. These are good for, again, I'll change. I'm going to get real colorful today. So this would be c squared in this equation here. C is always your hypotenuse, and your hypotenuse is the longest line in a right angle triangle. It's the one that's across from the 90-degree angle. So, and then this, we'll just call this one A and this one B. And really, it doesn't matter. This could be B and that could be A, but we'll just keep it simple this way. A, B, and then C's over here. All right. So the question is, how do you solve for the magnitude? This is how. How do we solve for the angle? We're going to use SOHCAHTOA, but we'll figure out which one we need to use there. So first, let's do the magnitude. And remember, vectors have magnitude and angle or direction, so we'll do both. So we have c squared is equal to a squared plus b squared. Okay, and that means that c is equal, wow, sorry about that, is equal to a squared plus b squared. If you're thinking that looks really similar to this, that's because it is that, basically. And so we put in the values. A squared is 35 kilometers. I'll just put brackets around that. Plus 15 kilometers. That squared is inside that, right? There we go. Let me just draw that again so that it's all inside. Don't want to be there any confusion there. All right, and then the answer is C is equal to, and now I'm just realizing that I did not pre-calculate this. So I'm bringing my calculator out here, and this shouldn't take long at all. But I should have pre-calculated this just so that it would be a little quicker. All right, I'm using my phone, so I got to put it sideways. So this is 35 squared plus 15 squared. And all of that is, so we're going to take the square root of that. So it is 38.0 Whoa. Can't look at my calculator and the screen. I always have to look at the screen, is what I'm trying to say. 38, 0, 7, 8, 8, and so on. Now this is kilometers, and we should round it. And we have 2 significant digits given in all of them, so this would just be 38, because the 0 won't change the 8 there. It'll stay the same. Okay, now that's just the magnitude. We're not quite done. We need also the angle, and really you could find any angle here that pertains to this line here, but I think the one that makes the most sense in our diagram is going to be this angle here. Okay, so being really picky, really hard on myself here, and maybe I should just be good with it, or be more careful, one of the two. So that angle, and now to find that angle, that's where you use the SOHCAHTOA thing. SOHCAHTOA just is the sine of theta. Let's call this theta here. This, I don't think I can put theta in there. I'm so careful. Theta, it's a Greek letter. Boom. So this would be the sine of theta is equal to your opposite over hypotenuse, and opposite is just the line that's opposite the angle, and hypotenuse is always the longest one, and this would be adjacent here. Okay, so this would be opposite. I can just go O. This will be hypotenuse, and this will be adjacent here. Okay, so you can see this is opposite over hypotenuse. Hopefully you already know this, but if you don't, remember. This one is the cosine, so I'll just draw it down here. The cosine of theta is equal to the adjacent over hypotenuse, and the last one is the tan of theta is equal to the opposite over adjacent. And if you look at this, we have the opposite and the the opposite and the adjacent. We do now know the hypotenuse, so we could use that, but we're not going to, because we want to use the ones that are given in case we screwed up here. So opposite over adjacent, that's just the tan, and you're going to notice here this is going to end up looking like that again, but let's put this down. So the tan of theta is equal to the opposite over the adjacent. So therefore the tan of theta is equal to 50. Oh, you know what? I should rearrange it. Let me just erase that. So let's make theta all by itself, and so we go theta is equal to, what you want to do is you want to take the tan inverse of both sides, the tan inverse of this as well. Making a mess of things, but it works out. The tan inverse of tan, they cancel out, and so you're left with theta equals the tan inverse of opposite over adjacent. And in this case, the opposite is 15 kilometers, and the adjacent is 35 kilometers. And now we just calculate this. And again, I'm going to use my calculator here. So I'm going to, oh, and it's the tan inverse. So on my phone, I need to click on, I need extra features basically, or extra functions. Tan inverse, or a tan of 15 divided by 35. And I get 23.198 so on degrees. Now, you got to think, is that reasonable? Yeah, I think it's reasonable. If this was long, that was a little bit shorter. This is definitely could be less than, it should be less than 45 degrees. And we're going to round this to 2 significant digits, like that. And that's a degree sign, not another 0. All right. So I think I'm going to stop here and then do this question again. But this time I'm going to do it with the right values, the correct values here, and not the correct angles, I should say. Because I changed this into a right angle question, and you'll notice that some of the questions following this one have right angles, but this one doesn't. So I will redo another video. Hopefully I can do this quicker next time. And then expect to have a third video after that that discusses a a more beautiful, more complete method for all of this. See you soon.